Good afternoon, students. In the previous class, we have already discussed about molding sands, their ingredients, properties, some of the molding machines we have discussed in detail about this. So, those are used for medium to large castings with use of what different molding machine. Then we will discuss different molding process in this class. So, among those green sand molding, it is the most widely used molding process. So the green sand is used for molding processes, which consists of silica, sand, clay, water, and other additives. So green sand mixture contains 10 to 15% clay binder, 3 to 6% water, and the remaining binders and silica sand. So green sand mixture is prepared and mold is made by packing the sand around the pattern. Cope and drag are assembled and molten metal is poured when the mold cavity is neither dried nor naked. So this method is mostly preferred for making small and medium castings and suitable for non-ferrous castings. The parts like railing and gates, molding boxes, grills, then weights can also be made by with this method. So this concept we have already discussed in the earlier class. So I will glance this what molding processes using this. Then you look at this picture. Then so this is exactly the what process of producing molds by green sand molding. Then green sand nothing but about when the sand is available in moist condition. Then such what sand it is consisting of what water about 8 percentage by weight of molding sand, then 90 to 95% silica grains, then along with this small percentage of additives, then are all thoroughly mixed in a muller or a mixture. Then the sand it is ready for what packing around the pattern. Then so as we already discussed in the green sand molding, the pattern mold box we have to select, kept over the mold board. Then and in the what on the mold board pattern we have to keep it, and the mold box already inserted. Then so then prepared sand it is packed around the pattern then and rammed thoroughly. Once dense packing takes place, then so then it has to be reverted as shown in the figures B. Then so here then again another half of the what mold, then cope we have to prepare in the similar fashion by arranging runner, riser, cope pattern, all we have to kept on the what pattern. Then again fill the what prepared molding sand, then ram thoroughly. Once if you ram it, remove all the what runner, riser, everything. Then both the boxes you have already clinged then are locked. Then put vent holes for easy escapement of gases. So then once it is ready, then you have to separate the mold boxes, remove the what pattern. Then after removing pattern, then so you have to coat the what mold by using ceromol coat or simply mold wash they call it as. Then so after what washing, after applying all these wash, then that becomes slightly refractive. Then in that you are required to pour. By the time it is ready for pouring, simultaneously you are also preparing molten metal in the furnace. Then same thing, it is to be transferred into the ladle and pour it into the mold. And once if you pour it, then so the mold it is subjected to the solidification. Then after solidification you break remove the mold boxes and what take out the casting. That is exactly the what green sand molding as we discussed in the earlier class. And again with respect to the molding processes, green sand molding it is of the same procedure. Then coming to the what other what sand molding process, then that is dry sand processing. This method is almost similar to green sand molding, except that the composition of sand constituent is different in this case, slightly vary with the composition of the molding sand. While preparing dry and mixture, then special binding materials like resin, clay, molasses are added to give strong bond to the sand. Then hence the dry sand mold possesses high strength than the what green sand. Then dry sand molds are more permeable than green sand molds because they are heated in a water. Once the green sand molds are prepared and heated in an oven between 150 to 250 degrees centigrade to drive up the moisture content, so this will remove the moisture, hence it becomes dry, become very hard, tough, durable, and what gain a edge hardness and all. Then so casting produced by this method possesses clean and smooth surfaces, no doubt. Then as compared to green sand molding, this method produces casting with fewer defects. Defects are minimum also because we are drying this mold. Then when moisture content comes in contact with the hot molten metal, many of the defects are rising. Then this tendency it is not available with the dry sand molding. But the main advantage of this method is that it requires more labor and consumes more time in completing the mold, and mold baking is also an extra work. Then so all these are extra work you needed. Due to high cost and time consuming process, it is not used in mass production. It is used for production like large rolls, gear housings, machinery components, etc. But all can be able to produce that. This is exactly the what dry sand molding. Then coming to the what shell molding. Then so shell molding is suitable for thin walled articles. Then normally highly delicate thin parts are produced with the help of shell molding. Then so even then parts which are defect free and somewhat complicated to produce by other means can be able to produce with the help of shell molding. Then so this shell molding process is suitable for production of some of the what castings like precision castings, we can say this. So this shell molding normally shell molding involves making molds with thin shells from a mixture of fine silica sand of about 100 to 150 mesh and thermostatic resin binders. The presence of clay is not necessary in the mixture. Then in fact, if a clay present, it affects the smooth flow of resins, and the resin binders are about 3 to 10 percentage by weight. Normally phenol formaldehyde or urea formaldehyde, alkyds or polyester resins are normally employed in the shell molding process. The resins are used in the form of dye powders or the dry powders. Shell molding process involves so many steps. Then so initially you look at the picture. Then so these are the what shell molding process procedure. The first step is to preparation of the shell molding mixture. Then so fine silica sand is mixed thoroughly with about 5 percentage by weight of plastic resin binders in the dry form. Then in a container, the amount of resin binder depends on the particle size of the silica sand used. Then the finer the sand size, higher the quantity of binder. Quantity of binder is required is more than, which gives good surface finish on the casting. Coarser grains require less quantity of binder but will not yield a smooth surface on the casting. Then first step it is purely related to the molding mixture preparation. Second is a pattern heating. Then so the pattern normally it is made up of carbon steels to sustain high temperature. The pattern is fixed in a pattern plate provided with the ejector pins. The pattern and the plate is first heated between 200 to 250 degrees centigrade in a furnace or using gas torches. The heated pattern is sprayed or brushed with the silicone oil to facilitate easy stripping of the shell from the pattern. So this is very important. So otherwise the shell molding mixture may be stick to the pattern. So don't forget to what apply the what silicone oil to this is exactly required for separation of shell from the pattern itself. So once if you hit the pattern, it is to be kept on the dump box as shown in the figure. Then the obtaining the shell, the pattern plate is then placed on the top of the dump box containing the sand mixture in the sand resin mixture. The dump box is inverted so that pattern gets conveyed as shown in the figure 2. Then we are required to upside down the dump box. Then the sand available in the dump box will made to fall on the heated pattern. Then the dump box is inverted so that pattern gets covered by the sand resin mixture. The resin melts and is about and in about 30 seconds the pattern will be coated with the shell of resin bonded sand. And the shell will be quite hard because of thermosetting resin binders. The dump box is turned back to its original position so that surplus sand mixture falls back into the bottom of the dump box as shown in the third figure. Then so next step is to what stripping, obtaining and stripping the shell. Then the pattern plate is then removed and with the adhered shell is heated in an oven for 2 minutes at 300 degrees centigrade. This is exactly called it as what curing means. Curing and stripping of the shell is the another step. Then so what to do then? The shell, the pattern along with the shell you have to take it and heat it in an oven for 2 minutes at about 300 degrees centigrade. This is exactly called as what curing. Then this hardens the shell. The shell is then stripped from the pattern plate by means of ejector pins or by operating ejector pin. Then that is another step. Then so then similarly another half of the shell we have to prepare. These what prepared shells are to be assembled again. Then so next step is assembling and keeping in the mold box. Then another what shell is prepared in the similar way and both hollows are assembled together either by adhesives or by clamps or by spring clip. Then this is placed in a mold box as shown in the last figure and surrounded with the surplus material like wire sand, metal shards, gravel, waste sand here and there thrown in the foundry floor. Then that you have to pack it around the what shells. Then so now it is ready for pouring. Then so last step is to what pouring and cleaning. The ready mold is poured with the molten metal. Then after solidification the casting is sent for cleaning and inspection. Once if you clean it and take out the casting, then that is ready for what specific purposes. These are all the what procedural steps involved in making what casting with the shell molding. So advantages then, so very high quality casting is obtained with the surface finish and close dimensional tolerances. Then the process requires less sand handling, less sand and handling the shell is easier. Then it gives a high rate of production with limited floor area. Molds and cores can be stored for future what use that because they are non-hygroscopic. They are not at all absorbing the gases or moisture contents constituents from the atmospheric air. Then permeability of the shell is high. Then hence gases escapes readily through them. Then less floor area required. Casting defects are very minimum. Then after cleaning the casting is directly used without any machining. No chances of sand inclusion. All these are the what advantages. Then limitation. Then the pattern equipment cost is very high. Then pattern cost is very high, not economical for very few parts production. Then complicated jobs cannot be molded. Then size of the casting is limited. Then suitable only for limited size and weight. Then relative inflexibility in gating and raising as they are to be provided in the shell itself. Then so this is not create a lot of problem. Then but however then you can able to produce what castings with without defect and good surface finish and close dimensional tolerances. This is exactly a what um, shell molding process. Then coming to the other molding process, that is what sweep molding. Then so as we already discussed this topic with the help of sweep pattern, then Again we'll discuss that. Sweep pattern, it is a just a form made of a wooden board which sweeps the casting shape into the sand all around the circumference. Then you look at this. So it consisting of a vertical post, then pattern it is attached to the vertical post by using hinges, and this it is placed at the center of the mold boxes. The equipment consists of a base placed in the sand, vertical spindle, and a wooden template called a sweep. You can call it as exactly. The sweep is rotated about the spindle or post to form the cavity as shown in figure. Then once the mold is ready, then sweep pattern and post can be removed. Then the initially one half of the pattern it is kept at one side then and pack the sand around us, and once it is densely packed, then the whole post is rotated to the other side. Then once it is rotated to the other side, again we have to fill the sand and pack thoroughly. Then once it is packed thoroughly, then the mold it is what ready now. All post spindle we can take it out, and that imprints the what mold cavity in the mold boxes. So it saves lot of time and labor cost as compared to making a full pattern. So patterns are used for making a large casting of circular sections and symmetric shapes. For example, like large kettles of cast iron, flywheels, gear blanks of large one are able to produce that. Normally symmetric circular castings can be able to produce with the help of sweep molding. Then another very important casting process, that is carbon dioxide molding. Then so this is very important again. Then carbon dioxide molding, it is repetitively asked in the examination. Then so you try to concentrate more about this. Then so this process is more suitable for core making as it gives high strength and refractiveness to the what cores and mold. Then it can also be used for making very small to medium size molds. Then so in this, silica sand is mixed thoroughly with the sodium silicate solution. Silica sand is mixed with the sodium silicate solution so that the individual grains of sand are effectively coated. The required mold or core is then rammed with the mixture. The carbon dioxide gas is passed through the rammed sand as shown in figure. Carbon dioxide reacts with the sodium silicate to form silica gel as we shown in the reaction. Then the silica gel is formed, act as a strong bond between the silica sand grains, and this process takes place without the application of it. Normally in core making, the carbon dioxide gas is passed while the core is in the core box and it hardens then. So you look at then picture will show you. Then here it is what carbon dioxide molding. Then mold preparation is exactly similar, only the thing is that silica sand grains are mixed with sodium silicate solution. No other additives are added. If required, then slightly wood cereal and cellulose powder can be added for improving collapsibility property for the molding sand. And later, as usual in the mold boxes, we have to keep the pattern and prepared sand it is packed around us, and similarly another half of the mold we have to prepare them. So once it is prepared, then so gas would vent we have to perform in the what mold. Then so on the top, on the top, then again we have to fix a funnel pipe or gassing wood then to pass the carbon dioxide gases. As the carbon dioxide gas passes into the mold, then the sodium carbon dioxide reacts with what sodium silicate solution. Means carbon dioxide gas we are passing, and sodium silicate solution it is already available in the molding sand. So when carbon dioxide passed into the molding sand, so the sodium silicate reacts with carbon dioxide sodium carbonate and sodium silica gel it is formed. This silica gel formed is so coated over all the grains, hence mold become very tough, refractive and hard then. So this it is normally used for precision casting then. So all these procedure here they have mentioned along with the reaction then. So this is very important for the examination point of view. Again you have to go through them. So then advantages then labor cost and floor space are saved by avoiding drying or baking of the mold. No question of baking the mold in this procedure then. High accuracy and good surface finish of the casting are possible. Withdrawal of the pattern is facilitated since the mold may be hardened before extracting the pattern then. So before immediately we have to remove them and pass the gas then. So mold cracking and deformation are prevented, as in the earlier case then if you heat the mold then cracks are formed, but in this case we are not at all baking then, hence no cracking then. The process can be mechanized for mass production, main number of sequence and minimum operation then, hence we can easily adapt it for what mass production then. Less skill is required as compared to dry sand molding then. Minimum allowances can be reduced on the pattern because high quality pattern it can be able to produce. The disadvantage is molds and cores are more expensive, difficult to reclaim the sand because once it is formed and collapsed after solidification, the sand it is difficult to reclaim. The life of the sand mixture is short then. Molds and cores deteriorate if they are stored under normal atmospheric condition because carbon dioxide reaction it loosens if you keep it for longer time then. So that's what it is not use it for storing, as and when you prepare you can use it for molding and later for obtaining the casting then application parts of valves, pumps, compressors, machine tools, wheel castings, railway components, diesel engines and gear castings and many other industrial applications can be obtained with this CO2 molding process then coming to the other molding process, that is investment molding. So this is exactly called, it is about last wax process or precision casting process, as all the three in our investment casting, all these terms are applicable to one casting process only. Investment molding nothing but what, in the molding process special investment mixtures are packing around the shells then, hence the name investment casting. Last wax process, in this process then there makes use of a disposable or expandable patterns like wax patterns are using, and these wax patterns are get lost after forming the shells then, hence the name last wax process. And precision casting, highly precise and highly surface finish casting, very small to medium casting can be able to produce, hence the name precision casting process then. So all these terms are applicable to only one term then. So this process is also, hence the name, all these terms are applicable. In this process then disposable or expandable patterns are used, I said then. So those are all wax patterns. This is suitable for production of precision parts then. This process was extensively used for the production of precision machine parts during World War II. However, the basic principle of this process were discovered and applied thousands years of ago in Egypt, China and many other parts of the world for casting statues and other artistic parts. In the recent years, it has been popularly used for making golden inlays by the dental surgeons, and this process has been used successfully for the production of turbine blades or jet engine blades. And this process involves so many steps. Then you look at the pictures, I will what explain the what process then. So some of the important process procedural steps involved are dye and pattern making then. So for making wax pattern, suitable metal dyes are required. These dyes are made either by machining or by casting a low melting alloy around the metal master pattern. Usually dyes are made it into two hollows then, for easy and quick operation. Usually steel dyes are used, which gives smooth surface finish and a longer life then wax patterns are prepared by injecting molten wax at about 75 degrees centigrade at a pressure of about 3.5 to 7 Newton per millimeter square into the metal dies. The dies must be provided with the allowances for both wax and for the metal casting later then, that is clearly shown in the first figure then. So the what molten wax it is injected into the dies then, at about 75 degrees centigrade and allow it to solidify. After solidification, these dies are made it into two hollow then they open and take out the what wax pattern then, and these wax patterns are assembled to the what board then. That is exactly called it as a what assembling. The wax pattern and the gating system must be assembled if the casting if cast separatively. It can be joined by heating the surfaces to be attached or using some adhesives. The assembly is then fixed on a flat plate as shown in the second figure then. Later then the third step is what free coating. The wax assembly is then dipped into a slurry of refractory material. The slurry is made up of silica flour suspended in ethyl silicate solution. So how they are preparing slurry, silicate slurry, it is very important then. So the slurry is made of silica flour suspended in ethyl silicate solution. Since the slurry coating applied onto the wax pattern surfaces forms the real surface of the molding after taking out of the wax, then its fineness determines the surface finish of the final casting. The thickness of the primary coating is in the range of 1 to 1.5 mm. The assembly is then taken out and sprinkled with a coarse grained silica about 40 to 50 mesh and allowed to dry in air for 2 hours then. The coarse silica and the fine silica helps to produce a better bonding between the primary coating and in the investment backing then. The investment backing it is later filled around the what shells then. So however then, so these what shells once assembled over the board then are made to dip in a ceramic slurry. Ceramic slurry it is nothing but a what silica flour suspended in a ethyl silicate solution to form the primary coating, and later they are applying a what rough coarse sand over the shells after taking it out. That is exactly called it as what free coating. The next step is what investing then. The wax assembly is then invested in a mold then. So you look at the picture then, the assembly is inverted on a table and surrounded with the paper lined steel flask, that is exactly shown in the fourth figure then this what investment molding mixture is poured around the shells then. So this investment molding mixture it is of about consisting of about 90% silica, 5% alumina cement and 3 to 5% ethyl silicate. So they are thoroughly mixed each other. 90% silica sand, 5% alumina cement and 3 to 5% ethyl silicate, that is mixed thoroughly. That mixture exactly called it as what investment mixture. The table is vibrated and the mixture settles by gravity around the assembly. In the fifth figure they have shown then. So means the whole table it is filled with the what investment mixture and it is fitted on the table or fixed on the table, and the table is made to vibrate. So this settles the what sand in air about air. Then the investment is allowed to dry in air for about 8 hours. Then next step is what dewaxing and free heating. So in the fifth figure itself, once it is fixed and vibrated on the vibrating table, then now it is in the inverted position itself, the wax is melted out of the hardened mold by heating in inverted position in an oven at about 120 degrees centigrade. The wax may be reclaimed and reused. Means all wax patterns melt and collect the bottom. The mold is then preheated to a temperature of between 600 to 900 degrees centigrade. Once the wax patterns melt out, the whole mold box it is heated in an oven between 600 to 900 degrees centigrade. Then this preheating ensures that the metal will not chilled, and metal will not be chilled, and help for filling molten metal in the mold cavity. Means gas entrapment takes place, or mold may be cool, then so it become hygroscopic, absorb the moisture. Then that is the what reason you are free heat between 600 to 900 degrees centigrade in an oven. Then so once it is dried, it is inverted or bring back to its original position, then it is ready for pouring. Then molten metal is gravity filled into the sprue as shown in the sixth figure. Then so air pressure also if required you apply along with the molten metal. So after solidification, means once completely filled the molten metal into the mold, then it is allowed to solidify. After solidification, the whole box it is removed and it is sent for cleaning. Then casting, where the casting properly solidified, that is removed out and cleaned. So that is exactly the procedural steps involved in investment molding or precision casting or last wax process. Then coming to the all these are procedural steps available here. Then so all steps we have explained now. Then what are the advantages? Then so high degree accuracy and surface finish is obtained, because high surface finish is very high, close tolerance is very high, tolerance is also high, dimensional accuracy is also high. Therefore high degree of accuracy and surface finish is produced. Then the process can be adapted for all types of metals and alloys. Even high temperature alloys can also be melt and pour it into the shells. Complex shaped parts can be produced. Because of high surface finish, machining can be eliminated. Close control of mechanical properties is possible. Then castings are generally defect free. So all these are the advantages. Coming to the limitations, size of the casting to be made is limited. Then means very small to medium casting only, suitable only for small sized castings. Molds are single purpose only. Once if you use it, you have to collapse. Then every time you are required to use a new mold with a new wax pattern. Then cost of investment is very high compared to all other molding process. It is time consuming process also, because number of hours taking to dry the mold, about more than 8 hours, and more than 10 hours per cycle it may takes. Then so that's what it is a lengthy process. Then coming to the applications, parts for aerospace industries, aircraft engines, frames, fuel systems, etc. Parts for food and beverage machines, computers and data processing equipment, machine tools and accessories, nozzles, buckets, blades, etc. for gas turbines. Costume jewelry can also be produced with this investment molding process then. So this is very important for the examination point of view. I said then. So today's molding process, shell molding, carbon dioxide molding, investment molding are very important for the examination point of view then. So among these three, then anyone they may ask it then. Thoroughly you concentrate then. Oh, thank you then. Be safe at home then. Good day then.